Good day. We are looking at the brain sarcophagus. We're looking at part 2, and we've talked about electron configurations. And now we are going to move on. And let's see, starting with page 2, we're going to start looking at the size of atoms. So we have something called atomic radius, and that means we look at a sample, and the sample, let's say we have a bunch of copper atoms, and we can hit it with X-rays, and we can get the distance between two nuclei. So then you take that distance between two nuclei and divide it in half, and we say, you know what, that's approximately the radius of each atom. Now you don't have to memorize the 3 definitions for type of radius, but it's trying to show that they didn't come from thin air. Covalent radius, you're looking at a covalent molecule, and if say it's diatomic, again, you're just going to divide half the distance between the two nuclei. Now the atoms themselves would probably be slightly bigger because these things are actually going to overlap somewhat. And ionic radius, or radii, it's going to be the same kind of thing, except now we're looking at ionic compounds. But the bottom line is, these 3 things tell us about the size of atoms. Now, in a previous video, you learned about the trends in atomic radii, and now we're going to explain those trends. So you have to know the trends and you have to know why they happen. So let's look at this. Atomic and ionic radii increase down a chemical family, which we know is a group. So going down, no sweat. First reason, more electrons. If there are more electrons, and we got more layers, they're going to be farther from the nucleus, and naturally the atom gets bigger. The second reason we haven't talked before about, and this is the shielding effect. So when you have a large atom, you're going to have lots of layers of electrons in between the outer electrons and the nucleus. And the net effect of those inner electrons is they shield the outer electrons from feeling the full effect of the positively charged nucleus. So the shielding effect will apply to big elements that are low on the periodic table, but it's not going to apply to small ones like carbon, where you don't have many layers of electrons, and certainly don't have many layers of inner shells of electrons to shield the nucleus. So you have to know that as you go down a group, the atom gets bigger, and those are the 2 reasons why. Now let's look at going to the right. As we go from left to right across a row or a period, the atomic or ionic radii actually decreases. So why is this? Well, electrons are held by the nucleus. And even though we're adding more electrons as we go to the right in a row, we're at the same basic energy level. And so our nuclear charge is getting bigger. So we might have sodium with 11, and by the time you get to chlorine with 17 protons, you've increased the nuclear charge, and it can hold those electrons more tightly. If it holds electrons more tightly, they get smaller. So the greater nuclear charge, despite adding electrons, is what means atoms get smaller from left to right. So we're going to stop there, and we'll move to part 3.